All right, good morning, college algebra people. So we are going to talk about polynomials today. Okay, so we're just going to do a gentle introduction here. We're going to talk about the end behavior of polynomials. Okay, so let me go off and talk to us about what are we talking about? All right, so we have a polynomial, and what this is going to look like. Okay, it's going to be an a sub 0, a1 x to the 1, right, plus a2 x squared plus a3 x to the 4th plus dot 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 a n minus 1 x to the n minus 1 plus a n x to the n. Now, we write all of this out. It might stop here. Okay, it might stop at a0. Okay, there's no requirement that always have to be filled in. All right, it's just a way of saying it can go on and on and on to wherever you want to stop, but it could stop a lot sooner. Okay, you don't have to fill out a lot, right? Y equals 6 is considered a polynomial, right? The line y equals 6 is considered a polynomial. All right, so I wrote this in ascending form. Okay, where it counts up, it starts with a constant and then a1, x1 kind of a thing. That's fine, you're allowed to do that. Most of the time you guys are going to see this as a descending form, a n x n plus a n minus 1 x to the n minus 1 plus dot 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 a1 x1 and a naught. All right. Not this not. Okay, it means nothing. Not KNOT and not I'm not going to do this. Okay, not NOT. So yeah, there we go for what polynomials are. Okay, so what are the rules for what can you pick for your ANs? What can you pick for your X's? What are you picking for your N's? Okay, so generally your N's are whole numbers. Okay, so N's are going to be 0, 1, 2, 3, dot, dot, dot. Okay, we're not putting any negative numbers in here. Okay, we're not putting any fractions. We're not putting anything weird. It's just 0, 1, 2, 3, dot, dot, dot. All right. Your A's, right? Your ANs must be real. Right? X's could be anything. X's could be, any real number could be in an X, but these exponents have to be 0, 1, 2, 3, dot, dot, dot. All right. So things that are and are not polynomials. All right. So, like 1 over x squared, which is the negative exponent, not a polynomial. All right. If we talk about like the square root of x, this is equal to x to the 1/2, not a polynomial. Okay. So if I have 2 root x, this is not a polynomial, but root 2x is a polynomial. Okay, so notice the exponent on the x is just a 1, but the thing in front of it could be any real number, and that's fine. Okay, we're going to talk a little bit about complex numbers, imaginary numbers. So if you don't know what these are just yet, we're going to get here. If you have seen this before, then this is not a polynomial. Okay, but we are going to end up talking about this eventually, and when we get to them, we'll have a little review and a little introduction to what's going on with that. All right, but not a polynomial. This is not a real number. Okay, it's complex. All right, let's see. X to the 3/2. Not a polynomial. 3/2 is not an integer. It's not a whole number. It's not 0, 1, 2, 3, dot, dot, dot. It's 3/2, so not a polynomial. Okay, so they talked to us about what is and what is not a polynomial for a while. Okay, we have some notation to introduce to you. Okay, we're going to talk about the end behaviors. Okay, we're going to talk about end behavior. All right. So the first thing we have to do is talk about like how they're going to notate this. Okay. So they're going to use this symbology a lot. They're going to say x with an arrow goes off to infinity. Okay, and we read this as x approaches infinity. Okay, it's not a number. You can't ever set x equals infinity because we're never going to get there. It keeps going up, up, and up. I will tend to use slightly different verbiage when I'm talking about this. Like I like a more poetic way of saying it is like x tends towards infinity. Okay, or x grows without bound. Okay, so I'll use these two when interchangeably with x approaches infinity. I'll use this one too, but I'll tend to mix it up a little bit to say these different say it in these different ways, and that's going to apply to every one of these cases. All right. So let's see. We also have they really do they come out and they really beat you with this. So x approaches negative infinity. I'll spell it out. Okay, and like think about negative numbers, right? For adults, negative numbers are dead. All right, so just think about the idea of like you never pay your credit card ever again. All right, it's gonna get really big really fast, and eventually you're gonna be in a hole you'll never be able to dig yourself out of. So that's what this means. Stop paying your credit card, see what happens. All right, f of x goes to infinity. This is the y value, right? The f of x is the y value. Tends toward infinity. Okay, so fy or f of x approaches infinity. Usually the x, since you're picking, we'll say x approaches. Then we'll say y goes to, because it's like a kind of a consequence of your choice over here. So we'll say approaches infinity, but we'll often as not f of x goes to infinity. Yes, the Toy Story echoes in my head every time I hear this. Okay, so f of x goes to infinity and beyond. Okay. All right. And then again, it can go in a negative direction. Okay, so think of anything that can compile a huge amount of debt over time, and it just seems to never ever get smaller. Okay, so this is y value again, y or f of x goes to negative infinity. This is a little bit different from when I had college algebra. They did not do this kind of stuff to us. This is more of a calculus thought, which is why I don't like that it's in here, but so be it. I'll get you used to it early, right? Okay. So when we talk about the end behavior, there's two things we have to deal with. Okay. The degree of a polynomial. It's simply the highest exponent, right? If we have f of x is equal to like, 1 plus 3x squared minus 5x to the 7th, well, the highest degree is 7. So this would be a 7-degree polynomial. The a sub n here is negative 5. Okay, the leading coefficient, that's what they call the leading coefficient. I would say don't worry too much about trying to memorize all this vocabulary. We are going to use it. I'm going to say it as I'm pointing to this stuff for every problem we're going to do. Okay, so don't make yourself index cards with like leading coefficient. Try to memorize a formula and do all of that. I would much rather see you do the thing than be able to say the thing. All right, because generally they're going to reference it, but they're going to reference it in the context of a problem, and we're going to be doing so many of these. You're going to know. All right, so even though this might seem like a lot of notation, we're going to start using it, and you're going to be able to put that together. All right. So notice, right, it says leading coefficient, but it's listed last. Leading coefficient is just the number that's next to the highest x. That's all it is. Right. It doesn't matter where it is in the order, because you can reorder this any way you want, right? I mean, you learned this a long time ago. It doesn't matter if I take 3 plus 7 or 7 plus 3. Like, no, you can sort that the way you want, right? Or 3 plus 2 plus 1 is 1 plus 3 plus 2. Like, we can reorder any way we please. So yeah, so we have the degree, which is the highest exponent, and the leading coefficient, the number next to the highest exponent. All right. So why did I care about that? All right. Oh, we'll go to the next page. Okay. If your degree is an odd number, well, we'll do an even number. So it is an even number, right? So we're talking about quadratics, like we talked about in the last section. We're talking about, x to the 4th, x to the 6th, x to the 12th, anytime we have an even number here, okay? So the degree is even. There's two things that could happen, okay? We could have, a sub n, the leading coefficient, could be positive, or a sub n could be negative, all right? So we could have something like negative x squared, leading coefficient is negative 1, okay? So negative x squared, a sub n is less than 0. 3x to the 4th, a sub n is positive than 0, okay? So if it's positive, if its leading coefficient is positive, then the end behavior of a polynomial is going to look something like that. Okay, it's going to look a lot like a quadratic, right? A parabola that you have the first term is positive. Okay, so what we're going to say is as x approaches infinity, f of x approaches infinity. X approaches negative infinity. That means we're going this way, right? We're going to keep going here. F of x approaches still infinity, right? The more negative you get, the more positive this gets. Okay. With the other way around, right? Kind of like a parabola with leading coefficient negative, right? Same idea. We're going to have, right, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, okay, f of x approaches negative infinity, right? So the more negative you get, the more down here we are. All right. What if your degree is odd? If the degree is odd, right? That means x, x3, x7, okay, x to the 7. Then we have the same kind of an idea here, right? If my a sub n is positive, if a sub n is negative, right? What's going to happen? And if you remember going back to your transformations of graphs, we had you memorize certain shapes. So that kind of looks like an x cubed. Yeah, it does. All the odd polynomials kind of look like x cubed. I mean, not quite, but they're close. And then this one is in the opposite directions, okay? So, yeah, there we are. So what we're going to say here is as x approaches infinity, f of x, right, approaches positive infinity, right? As x approaches negative infinity, then f of x approaches negative infinity. See what happens with this one, like you get a negative 3x to the 3rd. If we put a negative number in here, we're going to have 1 plus 3. We're going to have 4 negative signs, so it's going to be positive. All right, that's what's going on there. So we're going to say as x goes to infinity, f of x goes to negative infinity. As x tends towards negative infinity, f of x tends towards positive infinity. All right, so that's pretty much what they're trying to get on this one, and the examples we're going to do in a moment pretty much capitalize on what's going on here. All right. So I didn't time this. I'm going to go ahead and stop our video here and say this is our introduction, and then I'm going to follow up with some problems on the next video. Okay. So I'm going to stop here, and I will see you in a moment to do some examples.